Hi everyone, this is Charan. Welcome to my channel. Today we are going to see about rename as well as replace in Pandas. So before going into the details, let's see why these two are very important. So as you see the sample data set behind me, so it has two unique problems. One with the name of the column, and second, there are some values which are highlighted as -1. So coming to the name of the column, in real life scenario, the data that we are going to work on would be stored in various systems, and the naming conventions of these systems would generally have details about the source system from which they are being captured, as well as the system in which the data is being stored, as well as like various other metadata about that particular attribute. So the name of those columns tend to be much more longer than it is actually required. And hence, like while using all these data set in our data science problem or the project, it doesn't make sense for us to retain the original name. In a lot of these cases, it makes much more sense to rename these with a name which is more intuitive while solving the particular problem. So that's why like a rename would be really useful. Also, rename can also be used to give a particular name to the index, or to rename the existing index with a new values and so on. And coming to the next one, which is replace. So in this particular data set, you can see there are few values which are highlighted as -1. So this is something like an error code. So for example, when an system is not able to capture the data for a particular day, so what would happen is those values could be missing. So if it is missing, we already know how to replace the value that is missing, or in some cases it would be sending an error code. So in this case, -1 is an error code, which means that the data was not able to be captured on that particular day. So we are going to see how to replace a specific value with a new value. So in this case, how we can replace -1 with a more accurate value, or like if we find an issue with a particular series of days, we want to replace those values with a new value, like how it can be done would also be explained in today's tutorial. So whatever we are going to see today will be really useful when we are going to work on a real life data science use case, or any particular data science project for that matter. So before going into the tutorial series, the data point for today is about number of Google searches. So this data is not publicly available, but it has been estimated that there are about 70,000 Google search requests that are getting processed every single second, which is roughly equal to over 1 billion in a day and over 1 trillion in a year. You can imagine like how huge the processing systems should be in order to handle such a huge request. And a small request, like if you find this video series useful, kindly give a thumbs up and subscribe to get notification about the new uploads, as well as if you think this would be useful for any of your friend, please feel free to share it with them. Come, let's go into the tutorial here. Let's get into the tutorial video now. So we are going to see how to implement rename as well as replace, which is the functionality of a Pandas library. So first is we need to import the Pandas library in order to make use of these functionalities. So let me execute this. As you see in my screen, so the data set that we are going to use today is the same search trend data set. So to show you the actual source data, so this is the actual CSV data, which is comma separated. It has the weight as well as various topics. The search trend store for all those topics for various weights. So this is something that is available for download for anyone. All you need to do is go to the Google search trend and give the topic that you want to search for, and you would be able to export the data in CSV, like for whatever time period that you are looking for. So now getting into the code. So first we will see about renaming a particular column, as well as renaming an index, as well as giving name to the axis. So first one is renaming a particular column. So the script for it is, first we need to pass on the data frame that needs to be renamed, and we need to use the keyword rename, which is an functionality of a Pandas library, and we need to mention what we are going to rename. So here we are saying that it is the column that we are going to rename, and so this is the original value, and this is the new value that needs to be renamed, or that it needs to be changed from machine learning to ML. So this is the original data frame. So let me execute this and show you what happens. So once I execute this, you can see, so this particular column, machine learning, has been renamed to ML. So everything else remains same, the data as such, everything remains same. It's just one of those columns is now renamed as machine learning, renamed as ML from machine learning. So let me see if I pass on a particular value which actually doesn't exist. Let's see what happens. So when I execute this, so as you see here, there isn't any error that is getting thrown. So all the column names remain same. So what would happen is this particular script would look for a column with this particular name. If this column is found, it will be renamed with ML, whereas if it is not found, there won't be any error. So when you are going to use the rename functionality, be very sure about the names that you are going to use, because there will not be any error thrown as an output, like if it is not found. So it will just execute and everything will be smooth. So you need to double check whatever column names that you are going to pass. So having explained how to rename a particular column, let's see how do we rename a particular axis. So here, so what happens is it's very similar to renaming a particular column, whereas what happens is we pass on the data frame, it's same. We use the rename functionality, which also remains same. But what we are doing here is we are saying that it is the index that we are going to rename. So whereas here we mentioned that it is the column name that we are going to rename. So here, similar to what we did previously, so we pass on the original value as well as the value to which it needs to be renamed. So here, index 0, we want to rename index 0 to A and index 1 to B. So as you see here, this particular data frame, so the index 0 is renamed with A and index 1 is renamed with B and everything else remains same. And going to the next one, let's say we want to give a name to the axis. So here we have a data frame, but we don't have a name to this axis. We don't have a name for the set of columns, or we don't have a name for the set of rows. So what we are going to use is we are going to use this data frame which we want to make these changes, and we are going to say rename underscore axis. So so by this it understands that it is the axis that needs to be renamed, and we pass on the value that needs to be given to that axis. And here by axis equal to rows, we mean that so this is the name that needs to be given to the rows, which is nothing but here, this one, and dot rename axis, and then this is the new value that needs to be given to the axis columns. So by executing this, so you can clearly see, so here in this data frame we did not have a name to the axis, but here we have topics for all the columns as well as we have dates as the name to the axis which has all the rows or all the indexes for that data frame. So now let's say we want to just pass on a new set of values. So here so far what we saw is we used to pass on the original value and then the new value to which it needs to be renamed. But let's say we want to rename the entire set of columns in a particular data frame. So it's not one specific column, we just want to rename the entire column names. So then what we do is, so as you see here, I'm just passing on the original data frame into a new one and then naming it as TD4, and let me just print TD4 to show what's in there. So if you see here, it is very similar to the original data frame. So now what I'm going to do is I'm going to pass on the new set of column names. So by mentioning the data frame dot columns, and within the square bracket I can pass on all the names that needs to be all the new names for the columns. And once I execute this, so what would happen is, as you see here, this is the original data frame, and now all the columns have been renamed to a new values. So let's say I am passing an additional column here. So let's see what happens here. So when I execute this one, So you can see there is an error that is getting thrown up because the data frame TD4 has only like 1, 2, 3, 4, 5, 6 particular columns, but we are passing 7 values to it, and hence it is not able to execute it. So what happens is an error is getting thrown up. So it says that there is a length mismatch. So expected axis has 6 elements, but we are passing 7 elements to it. So when I remove this additional value, so then it should be all right. So then there won't be any error. So let me just, so since this TD4 data frame is already renamed, so what happens is it still comes up with the renamed values. So that's fine. Like you can maybe try it out with having like maybe one less column, or with having like additional columns while passing on the values to the name of the column. So moving on to the next one. So let's say, like as we saw in the introduction, let's say there is a prefix that is getting added to the column names, and you want to remove those prefix. So in this case, like what we are saying is, I'm using the same data set here, but what I'm doing is I'm just passing a prefix to the data frame. So let's say, let me just re-execute the trend data to get its original values. And okay, so now let me execute this one. Okay, so now, so as you see here, the data frame TD5 has the column names, but some of the columns as an prefix dollar symbol. So let's say we want to remove these prefix. So as we saw like in the introduction, that could be some prefix to the data sets that you are going to handle. So these prefix could be the name of the systems or the source, or some metadata about that particular attribute. So if we don't want that, we want to rename or we want to remove those prefixes, what we can do is we can use replace functionality. So here, so what happens is we are saying that this is the data frame and the columns that we are going to change now. So here, for this data frame, for all the columns, we are going to use a string replace functionality to replace if there is any dollar symbol in the name of the column. So those needs to be replaced with an empty string. So when I execute this, so you will see that now the columns for which there was a prefix, the dollar symbol, is now removed. So they have been replaced with an empty string. So that's the functionality of using replace. So we can replace any particular prefix that is coming up in our data set with a new value, or we can replace it with an empty string. So the other replace functionalities or other methods to implement the replace are, so we can replace using the location, using the LOC method as well. So here, so just for ease, what I'm going to do is I'm just going to get a subset of the original data frame. So here, so this is the bottom 10 records of the same data frame. I'm just resetting the index to ensure that it starts with 0, and so that it's easier to show the demo when we have a smaller set of values. So now what I'm going to do is I'm saying I'm going to just print the value for the column which is named as data science, and then the row number 0. Okay, so now the column names are still not changing. So maybe what I will do is I will just re-execute this original data set trend data, and now what I will do is let me create this new data frame t underscore data from the original one. Okay, so now we have all the original column names, which is data science. So now, yeah, so the LOC method is used to identify what is the value in a particular location. So what we are going to do is we are going to execute this to see the value that is present in the column data science, and and in the index 0, which is nothing but data science is this particular column, and the index 0 would be this. So the value that we are going to check is this value 36. So we are using this to just print what the original value is. Now let's say we want to replace this value with a new value. So let's say we want to replace 36 with 40. So what we can do is we can simply pass on the new value that needs to be replaced. So this will do the job. So now, so what happens, as you see here, is so there is an data science column, and then the index 0, it was 36, but now it is replaced with 40. So as you see here, the first two values were 36, but now we have replaced it with 40. So that's how the alternate method of implementing replace. So there are some other ways, few other ways of doing it is we can also use at. So what we can do is pretty much the data frame as well as at the value. So instead of LOC, so here we are using at, and then the index as well as the column name and what should be the new value that needs to be replaced. So by executing this, so as you see here, so there was a value 36 here. So now it is being replaced with 40. So these are all the various methods in order to replace an particular value in a particular location. So we know exactly which value in which location needs to be replaced. So then we can use any one of these methods. So now let's see, we want to replace a particular set of value with the new values. So as we saw in the introduction, all those missing values were being encoded with a value of -1. So it is an error code, which means that the data are missing for that particular day. So in those cases, maybe we want to replace -1 with a new value. So in that case, we can use this functionality. So what it would do is, in this particular data frame, we use the same replace method, and we are saying whenever there is a value 40, it needs to be replaced with 42. So let me execute this. So if you see here, so all these values where it had 40 are now changed to 40. So there won't be any 40s. So whenever there is a 40 that is occurring in this particular data frame, it will be replaced with 42. And let's say how to do InPlace. So what happens is, in this functionality, so even though we are replacing, it is not changing the original data frame. The original data frame remains same. So if I execute this particular command, so you can still see the 40 remains in the original data frame. So it is not it hasn't been changed. But when we use InPlace is equal to true, so what happens is it would make these changes to the original data frame, which means that t underscore data would be impacted. So when I execute this one, so now what happens is, now if you see, so this script here, when we use InPlace is equal to true, what happens is it makes changes to the original data frame, and hence when we print the original data frame, it comes up with the replaced values. So the other ways is, so instead of just replacing one value, let's say we have a series of error codes in our data set. So similar to -1, there are few other maybe issues with the data set that we have, and all those records or all those values need to be replaced with a new value. So then what we can do is we can use all the set of values that we are looking to replace, and we can pass on the new set of values that needs to take its original place. So here what happens is 42 will be replaced with 142, 21 will be replaced with 121, and similarly 15 will be replaced with 115. So when I execute this one, so as you see here, all those values are replaced with the new values. The other ones are, let's say there are some values missing. So previously we saw how to handle all those missing values. So we were using is NA, and then we were using few methods like a backfill as well as forward fill. So the same techniques or same methods are also available in the replace functionality. So we are going to just see how it works in replace like functionality. So what I'm doing is I'm just using an slightly modified data set where intentionally some of these values are deleted. So that's why you see them as not a number. So they have been missing in the original file. So here the first one is the forward fill. So what we are seeing here is whenever the value is none, so which means that whenever we have not a number, so those needs to be replaced using the forward fill. So which means that let's say, so here in the index 10th position we have not a number. So in this case, when we use forward fill, so this particular value will be replaced by the value prior to it. So which means that it needs to be replaced with 31. So let's check what happened. So this is the index number 10. So what we can see is, we can see this is now replaced with the one with the value that is prior to it. So here similarly, so this needs to be removed. So whenever the value is null, if we use the batfill method, so let me execute it. So what happens is, so here in the 10th position, so this value was missing in the original file. So now when we use the batfill method, what happens is it is getting replaced with the value that comes after this, so which is 33. So these are some of the methods that we have covered in machine values as well. So these methods are also available with the replace functionality. Yeah, so that's it for today. So these are all some of the exercises that you can try. Trying all these exercises would definitely help you in better understanding these functionalities. And as I say like every time, please repeat all these exercises with a new data set and see how we were able to execute them. That could be some issues coming up which will be really good for you in your learning. And if you liked today's video, or if you have learned something new, please give a thumbs up and subscribe for for similar content related to data science. If you think that this would be helpful for any of your friends, please share it with them. So that's it for today. See you on the next session with a new topic. Bye until then.